Hello, grade 8 learner. Welcome again to another mathematics lesson. In this video lesson, we will discuss how to solve problems based on the theorems on angles formed by parallel lines cut by a transversal. This is based on the K-12 curriculum learning competency. The learner proves properties of parallel lines cut by a transversal. It's another great day to learn, so grab your pen, paper, and module as you watch and learn from this video lesson. Refer to your quarter 4 math module entitled Parallelism and Perpendicularity for this example. For this problem, we are given that lines A and B are parallel to each other. The measure of angle 1 is 4x minus 3, and the measure of angle 2 is 75 degrees. We solve for the value of x. Let us observe the figure. Identifying and classifying correctly the angles that are given in the problem is helpful in solving this problem. Let us process what we know. Let's try to identify the angles that are given in the problem. Can angles 1 and 2 be corresponding angles? Recall that corresponding angles are a pair of non-adjacent exterior and interior angles that lie on the same side of the transversal. We see that angle 1 is an exterior angle and angle 2 is an interior angle, and that they are non-adjacent. However, they lie on opposite sides of the transversal, thus they can't be corresponding angles. Can angles 1 and 2 be same side angles? Again, since they lie on opposite sides of the transversal, they can't be same side angles. Can angles 1 and 2 be alternate angles? While it is true that they lie on opposite sides of the transversal, one angle is an interior angle while the other is an exterior angle. That's why they can't also be alternate angles. So what kind of relationship does angle 1 and 2 have? To answer that, let us name an angle 3 on the figure and learn about the relationship of angles 1 and 2 based on their relation with angle 3. From their location on the figure, we see that angles 2 and 3 are corresponding angles since they are non-adjacent, interior and exterior angles that lie on the same side of the transversal. This means that angles 2 and 3 are congruent or have measures that are equal to each other. From their location on the figure, we see that angle 1 and 3 are linear pairs, or angles that share a common side and vertex, and whose measures add up to 180 degrees. This means that angles 1 and 3 are supplementary to each other, and as mentioned already, their measures add up to 180 degrees. Now, putting these two ideas together, we conclude that since the measure of angles 2 and 3 are equal, angle 2 can take the place of angle 3. With that idea, we can say that angles 1 and 2 are also linear pairs, which means that angles 1 and 2 are supplementary to each other. Let us solve. From our previous conclusion that angles 1 and 2 are linear pairs, and thus are supplementary to each other, we can translate that idea to an equation that the measure of angle 1 plus the measure of angle 2 is equal to 180. We then substitute the measures of angles 1 and 2, which are 4x minus 3 and 75 into the equation. We simplify the equation by adding negative 3 and 75 to get 4x plus 72 equal to 180. To keep only terms with the variable x on the left side of the equation, we transpose 72 to the right side to keep all constant terms on the right side of the equation. We simplify 180 minus 72 to get 4x equal to 108. Then, to eliminate 4 from 4x, we divide both sides of the equation by 4 to get the final result, which is that x is equal to 27. Let us state our conclusions. Given that lines A and B are parallel to each other, the measure of angle 1 is 4x minus 3, and the measure of angle 2 is 75, we solve for the value of x, which is 27. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.